So, what if everything you thought you knew about your brain's ability to learn, adapt, and grow was just entirely wrong? Welcome to This Explainer. Today, we're totally tearing down some of the biggest myths in human physiology and diving headfirst into this breathtaking frontier of brain research. We are going to uncover exactly how your everyday habits are physically reshaping the actual structure of your mind, literally at this very second.
For the longest time, the general consensus was that after you hit puberty, the only physical changes happening up there were negative. Losing brain cells as you age or suffering some kind of damage. We also kind of thought that when you were just sitting there zoning out, doing nothing, your brain was basically silent. Well, actually scratch that. Thanks to huge advances in MRI technology, we now know that couldn't be farther from the truth. Your brain is highly active even when you're resting, and far from being this static, unchanging thing, it is constantly reorganizing itself.
Here is our roadmap for today. 1. The constantly changing brain. 2. 3 ways you learn. 3. The struggle of practice. 4. No one-size-fits-all. And 5. Build your desired brain. Let's get right into it. Section 1. The constantly changing brain, the end of the static brain myth. Okay, so the absolute key to all this is just one word: neuroplasticity. Basically, every single time you learn a new fact or master a new skill, you are physically changing your brain. And honestly, the best news, these changes are absolutely not limited by how old you are. They're happening all the time. Neuroplasticity is the ultimate key to human adaptability, man. It is the engine that supports the whole shebang. Everything from picking up a new hobby in your 50s to recovering your motor functions after something as traumatic as a stroke. Section 2. 3 ways you learn. The scientific mechanics of brain change. Let's lift the hood for a second and look at the rule of 3. Because your brain doesn't just change in one simple way. It actually changes in 3 very distinct foundational ways to help you learn. These are chemical changes, structural changes, and functional changes. Now, while they can happen on their own, they almost always take place in concert, working together beautifully across your whole brain. Now, these first 2 mechanisms play out on completely different timelines. Chemical changes, those are super rapid. Your brain quickly increases the concentration of chemical signals between neurons to support short-term memory. Imagine you're learning to juggle, right? You practice for an hour, you totally nail the trick, and you think, awesome, I've got it. But then you try again the next day and no way, you've completely lost it. What happened there? Well, you experienced rapid chemical changes, but those signals didn't induce the structural changes you need for actual long-term memory. Structural changes, on the other hand, take time. They involve physically altering the connections between your neurons, so what you see in the short term really doesn't always reflect true lasting learning. But when those structural changes do happen, the physical results are just mind-blowing. I mean, people who read Braille literally develop larger hand sensory areas in their brains than people who don't. Or, if you're right-handed, the dominant motor region on the left side of your brain is physically bigger. And there's this famous example of London taxi drivers. They spend years memorizing this massive, incredibly complex map of the city streets, and because of that, they develop noticeably larger brain regions devoted entirely to spatial and mapping memories. Intensive practice literally inflates specific regions of your brain. Then we have the third mechanism, functional changes. Step 1. You use a brain region repeatedly. Step 2. That region becomes super excitable and much easier to use the next time. Step 3. As these areas get more excitable, your brain actually shifts how and when they're activated. When true learning happens, we see whole networks of brain activity literally shifting, changing, and becoming hyper-efficient based purely on your habits. Section 3. The struggle of practice. Why learning feels hard. So if our brains are so adaptable, why doesn't this happen effortlessly? I want to heavily emphasize this point. The primary driver of neuroplastic change in your brain is your behavior. Simple as that. There's no magic neuroplasticity pill you can swallow to suddenly speak French. Nothing is more effective than practice. To learn a new motor skill, the dose of practice required is just incredibly large. Bottom line, you just have to do the work.
But for anyone out there trying to learn something new, this next bit should be super reassuring. We all get so frustrated when learning feels difficult, right? But research shows that increased difficulty and struggle during practice is actually a biological green light. That frustrating feeling of struggle, that means you are actively forcing your brain to undergo greater structural change. You're literally carving out new neural pathways in real time. So when it feels painfully hard, that's how you know it's working for sure.
I do have to give you a quick warning, though. Neuroplasticity is absolutely a double-edged sword. It can be incredibly positive, like learning a new skill or building a healthy habit, but it can also be highly negative. Forgetting something you used to know, falling into drug addiction, or even developing chronic pain, those are all driven by the exact same biological mechanisms. Your brain is continuously being shaped by everything you do, and, maybe more importantly, by everything you don't do.
Section 4. No one-size-fits-all. Debunking generic learning rules.
Okay, we've all heard this famous number, right? The popular idea that it takes exactly 10,000 hours of practice to master a new skill. Well, modern brain science assures us it is really not that simple. For some of us, mastery is going to take a lot more practice than that, and for others, it might take way, way less.
Why? Because patterns of neuroplasticity are highly variable from person to person. For the longest time, this variability drove researchers absolutely crazy because it made designing standardized medical treatments super difficult. But now, scientists are realizing that this variability is actually the most important data we have. The shaping of our plastic brains is just far too unique for there to be some magical one-size-fits-all recipe for learning.
So to get the best outcomes, especially in serious situations like stroke rehabilitation, medicine has to take a personalized approach. Think about how cancer treatments use genetics to match a specific chemo to a specific cancer. Stroke researchers are doing the same thing by looking at unique characteristics of brain structure and function. They call these biomarkers. By using a patient's unique biomarkers, doctors can match specific therapies directly to them. It turns out, honoring the brain's unique individual structure is the absolute best way to predict recovery.
Section 5. Build your desired brain. Empowering your personal learning journey.
Let's pull this cutting-edge medical concept right out of the hospital and apply it directly to your everyday life. What we've learned about the brain after a stroke applies to every single one of us. Because your brain's structure is totally unique to you, the future demands personalized learning. The uniqueness of your mind profoundly affects you as a learner, as a teacher, and as a parent. It's exactly why one kid thrives in a normal classroom while another totally struggles, or why someone might pick up Spanish effortlessly but can't hit a baseball to save their life.
And get this, that variability doesn't just exist between you and your neighbor, it exists right inside your own head. You have to adapt your learning strategies depending on the actual skill. You might sit down at a piano and find that learning music just clicks for you, meaning your brain only needs a small dose of practice for that. But put that exact same brain on a snowboard and it might be a total disaster at first, requiring a massively different approach and way more practice. You really have to figure out how you learn best.
So I really want you to think about this question right now, because when you finish watching this explainer, your brain will physically not be the exact same brain you had when you started it. Every single thing you do, everything you experience, it's actively changing your brain right now. So what behaviors are you going to repeat today to keep your brain healthy? And maybe even more importantly, which negative habits are you finally going to break?
As brain researcher Dr. Laura Boyd perfectly puts it, go out and build the brain you want. You are literally the architect of your own mind, and every action you take is a building block. Are you laying down the foundation for a resilient, adaptable brain, or are you letting negative neuroplasticity call the shots? So starting the very minute this explainer ends, what kind of brain are you going to choose to build?